Hello everyone, and welcome to the Spring Boot Quick Start tutorial by Dead of Night Studios. In this video, the viewer will become familiar with developing Spring Boot microservices, the ins and outs of the Spring framework, and a little bit about the history. The viewer should already have some prior knowledge of Java and web development in order to understand all the concepts covered in this video. Let's go ahead and get started. So what is Spring? Spring is an enterprise Java framework developed back in 2002 by Pivotal that enables the developer to focus on the business logic instead of the nitty-gritty boilerplate code needed for various environment deployments. Some of the core features that it includes are validation, data binding, mock and integration testing, object relational mapping, various web protocol supports. The list goes on. You can see a full list of the features under spring.io, and you can see the list that goes on the left here off the page. Because there are so many various packages and dependencies of Spring Framework, and since every application doesn't necessarily need all of them, Spring Boot was invented, which is a very minimalistic Spring application designed to get the developer up and running as quick as possible with an embedded Tomcat server and easily configurable variables to make sure that it's fault tolerant and scalable in whatever environments it's deployed, as long as it has a Java Virtual Machine or JVM on that environment. So for this tutorial, we're going to be using Linux Mint operating system with OpenJDK, our Java development kit here, in order to compile and run our application. I'll be developing my code in Eclipse, which is a great IDE. It's free and easy to run. There's also the Spring Tool Suite, which is Eclipse with the Spring Tools plugin already installed. It occasionally needs to be updated to the latest version of Eclipse, so it might be a little behind depending on release schedules. But IntelliJ is another great alternative. I just think you have to pay for the Spring Boot plugin on this specific IDE, and for this one we'll still be using Eclipse. So let's go ahead and switch over. So this is what vanilla Eclipse looks like installed. You should just download the zip file, extract everything, and double click the Eclipse install, which will give you a shortcut if you need one. And once you have it up and running, go ahead and click Help and go to Eclipse Marketplace, and we're going to need to install the Spring Tools. So go ahead and search for Spring Tools at the top. And as you can see here, Spring Tools 4 is the package we'll need. I already have it installed, but it'll be by VMware, and it should have quite a lot of installs. But once you have it installed, you'll need to restart your IDE, and with it restarted, you should be able to go to File, New, Other, look for Spring Boot folder, and then under Spring Boot is the Spring Starter project that we'll select Next on. And this will be our little project creation wizard. So we'll be creating a menu microservice, which is just a small microservice for a restaurant to provide users access to the menu items there, and they'll be able to manipulate or view any changes as we go and expand this application. So let's go ahead and name it menu, set the Java version to 8. We can select what type we want for the build configuration and dependency management. I'm going to go ahead and use Maven for this one. I'm just more familiar with it. Gradle is slightly faster with the compile time, and it is taking a strong hold in the marketplace, but Maven does have a lot more support and documentation. For this video, we'll be using Maven. We'll keep the artifact name the same. For the group, it will be the company dot my company, or whatever your company's name is, dot the service name, in this case menu, and we'll make sure that it's the same as the package structure so that it'll have a nice naming convention for easy identification. We'll keep our service version as 001 snapshot for now, and then we'll keep this description, which is just used to expose all the menu items. Keep it simple. So once you hit Next, you'll see a list of dependencies that we can add to our project at start. And as you can see, there's a lot of Spring Cloud dependencies, SQL, NoSQL, IO, developer tools, Google Cloud Platform, various services and features that you can include. But for this one, I think we're only going to use the Spring Web, the RESTful Spring Web support with Apache Tomcat. And you can find it under here if it's not under your frequently used, under Web. and you'll see the Spring Web dependency. Now there's also the Spring Web Services, which is SOAP support, I believe. Yeah, it has the XML payloads. We don't want that one. We're going to be using JSON and the RESTful practice and architecture here with Tomcat. So let's go ahead and hit next. I'm going to keep that the same. Let's go ahead and get started. So it's going to build and compile the code, and it'll print some results down here in the bottom right. Once it's done, the project should be created in the top left. If you expand it, you should see the source main Java and source main resources, which is going to be the main areas of our application that we're going to be altering. If you expand the source main Java, you'll see our package structure that we created previously, and if we expand that, we'll see the root application file, which has a Spring Boot annotation and a Spring Boot bootstrapper for the Java class already set up. So this just tells the JVM to load in some extra Spring Boot support and to run it as a Spring Boot application. If we expand the resources, we'll see application.properties. Here we can set a variety of global variables such as the server port, which we'll set to 8080. Here we can see here we can also see just the folder structure that we were seeing up here with the nice clean package structure. And this is just a direct folder breakdown of what the source code actually looks like, and just makes navigation a little bit more difficult, which is why Eclipse provides this nice easy package structure and naming convention up here for navigation. This is our target directory, which contains all our compiled code, and looks like we haven't compiled anything yet, so we'll do that in a minute. And then down here we have our help.md file, which will change to a readme.md for the GitHub support in a later video, and I'll leave that there. And we have our Maven Run Files, and looks like our Windows Maven command file, which we won't touch. And then we have our PALM file, which manages our application's metadata, including the parent dependencies, artifact versions and names, the targeted Java version, and then all the dependencies listed for this application. So right now we just have the Spring Boot Starter Web and the Spring Boot Starter Test, which is included by default. And I believe if we expand this source test Java, and we'll see another package structure here that contains a test application with more Spring Boot annotation, just so that we can make sure the application can load, and that's all this test does. If we have any configuration issues or compile issues, it'll try to run this and give us a warning, but we'll probably already know at that point anyway. So once we've gone through that, let's go ahead and see if it'll run, which it should, by right-clicking on the parent folder and clicking Run As, and going down to Spring Boot. So Spring Boot printed its nice fancy header. Oops. Okay, there we go. And no active profile set, that's fine. And that means that it'll just take the application.properties as the default, starting on 8080, which is what we wanted, and it started the application. So wonderful. Now we don't have any endpoints to hit right now. So let's go ahead and turn it off and go back to our source main Java and our first package. Right click on it, hit New, Class, and we're going to create a menu controller. And so we'll be following the MVC architecture, or Model View Controller, and this helps us break out our application, our entire web application, into slivers of logic that we can easily update and deploy separately so they're independent. And this is key in the microservice-oriented architecture, so that if one specific feature or service goes down, it doesn't affect or alter any of the other features. This way, your users will only experience minor hiccups or bugs if they were pushed out in whatever release cycle that you and your team are using. But for the back-end Spring Boot microservices, they only really focus on the controller and model aspect, leaving the view to Angular or React frameworks to render the data and display it. So the menu controller here is going to act as our central method or central class that exposes all of our methods to the public on the internet. So for that, we're going to tell Spring Boot that this is a REST controller by using @REST controller annotation, and make sure that it's a capital R. And we're going to import from the Spring framework. And so this just lets Spring know all the methods created in this class with the proper taggings should be exposed for HTTP protocols to access. So if we go down here and we want to create a public get all menu items method, it'll return a response entity of a list of strings, which will just be the menu items, and we'll call it get all menu items. So go ahead and make sure you spell response right. Response entity and entity right. And then import from the Spring Framework .http, and then the java.util for the class, or excuse me, for the list. And then we go to return a new response entity of the same type with an HTTP status of OK. And in this case, it's always going to be OK, even if there's no data, just because we don't want to upset the user in any way. If there's no data, that's our problem. If there's a serious error where we're not able to access or run, that's slightly different, and we'll deal with that separately. But for right now, we're just going to return OK. And let's actually return some dummy data. So let's just create a list of strings, and we'll call it items. It'll be a new array list. Items.add, and we'll just call it item1. Copy it. Item2. Make sure you import your array list library from the Java util, and then return your items in the new response entity constructor, which accepts a object of the same type that you cast it to, and make sure that all your types match. So this is awesome. We have a method here, but Spring doesn't yet know to expose it. In order to do that, we're going to use an @get mapping, and we're going to give it a URL. So for this, we want /menu/items. Make sure you import your get mapping. Awesome. Awesome. So let's go ahead and see if that runs by right-clicking on the application, going to run as Spring Boot. And then we have Tomcat started on port 8080. So let's go ahead and open up a terminal, and we're going to use curl, and we're going to make a get call, and it'll be localhost 8080 /menu items. Oh, I guess we don't need to call get here. Yes, so no need to add get there, but just use curl localhost 8080 menu items, and you can see that we're getting back the list of items that we expected. So let's go ahead and clear that, go back to the console and our IDE, stop the application, and let's build another endpoint. And this one we'll call it get item by ID, or get menu item by ID. And this will accept a path variable ID of the same name, which we placed in the header mapping, or the mapping request. This needs to match the path variable name. This I don't believe has to match, but I like keeping it the same for consistency. And we don't need to return a list in this case. We'll just want to return a single string . And it'll just be your ID. that we return, just to show that we can get the ID. And it'll always be okay, because whether or not they actually add anything doesn't matter to us. We're still going to return. Let's go ahead and run our application as a Spring Boot app again. Make sure it's started. Go back to our terminal. Open up curl. And instead of menu items, we'll do menu items and we'll pass in hello world. So our ID is hello world. Awesome. So this is pretty straightforward, but as our logic expands and our needs grow, we're not just going to have a base set of in-memory data as an array list here. We're going to have a data source such as an SQL database, a MongoDB, or other NoSQL data source that we pull various things from, and we might need to do a bunch of additional logic on. So we're going to abstract this logic out specifically into a service, and for right now we'll still keep it as this dummy data, but we're just going to create a service to keep it nice and clean in the controller, because the controller here should really only focus on the mappings and exposing of the endpoints, and then any handling of responses in case we need to change status. As you can see, if you use the HTTP status dot, your IDE will suggest a variety of other statuses you can use. One of my favorites is I am a teapot, and I'm just going to use it here because I do not get to use it enough. So on every request we will turn I am a teapot status, which I believe is 418. Yes, 418. And let's go ahead and create a service. We'll call this the menu service. Create a class in the same package called menu service. Go ahead and give it the @service annotation so Spring knows this is a service. Let's create a class in here, a public list of strings, and we'll call it get all menu items. Import your list class, and we'll return items, which we will copy over from the controller. Cool. So this is still mocked dummy data, but will serve the purpose for now. Let's also make our get item endpoint get menu item by ID, and it'll accept the ID, and it should just return a string. Cool. So now here we will call our menu service, get all menu items, and then here or we'll just call it item equal menu service dot get item by ID. Make sure and return the item so we know the service logic is working. Okay. Go ahead and remove any unused imports. So the one thing we need to do here for the service is, since we haven't instantiated it and we don't really want to deal with the hassle of the native threading support that Spring provides, we're going to use the @autowired annotation, which means that however many instances or threads of this controller is spun up and however many services are needed, it will do the balancing for us and configure it accurately, so we don't have to go create the instance in a constructor and then perform the proper garbage collection afterwards as needed, even though Java itself does have a timed garbage collection. So let's go ahead and import the autowired Spring framework annotation, and that'll make everything connected and configured correctly. Another thing is, since both these endpoints are using menu, and I would like really every endpoint for this microservice to also have menu in the URL, I'm going to remove it from here in this REST controller specifically. Go to the application.properties, and in here add a I believe it is a servlet context path / menu, so that every endpoint exposed by this microservice has menu in the URL. So we go back here, and both these should still be / menu if we make a request to it. It's just we don't have to add that extra text here and keep it and update it if we suddenly change this to menu 2 or items or whatever we want to change this service in the future. But let's go ahead and shut off our old instance, make sure we save our code, and make sure that our application is still working as intended. This looks like menu item still works. Let's see if menu items is still returning a list. So this is awesome. Let's go ahead and stop the application. And I think we're going to need a little bit more data than just a string. So let's create a data transfer object. Or in this case, we'll just call it our model, because we don't need to convert it from a model into a more condensed or less data driven model. We will have a menu item. It'll be under the same package structure. This is going to have a private string name field, a private string price, which will include the $, perhaps a description as well. And I don't think there's anything else that we need right now. Let's go ahead and create a default constructor. And if we go below the default constructor, right click, go to source, generate getters and setters, and then select all of our fields, we can generate all the needed accessors for those private fields. And in this constructor, we're going to want to go ahead and pass in, well, we're going to want to make two constructors, a default constructor here, which accepts no parameters, and then one that accepts a name, a description, and a price. And then go ahead and assign those over. So that we can easily create menu items as needed. And then in our controller, we'll use menu item instead of string. We'll have to change it in every place. Same for get menu item. Then go to the service and do the same. And here we need to do a new menu item and then provide all the details. I'll set this one to $4. Close the constructor. Create two of them. Set 1 to 8. And there we go. And then here, if we just want to return a new item with a given name of ID. Oh, of course, and we should have a ID generated, which for us in our model will just be a UUID. And if you are using Eclipse, you can mouse over it if it's underscored with a yellow squiggly line, and there'll be a create getter setter. Quick shortcut, you can name them as you need. Just going to add those to the class, and on our getter and setter, the ID will be equal to a new UUID dot random toString. And this is just a algorithm that gives us a unique string. I believe it's based off of time for its uniqueness, and it is very, very hard to have a collision in the same string or generated sequence of numbers. We're just going to use it here as an example with its string format for every created item, and if it's just a default constructor, we will let it deal with it. So everything looks good. Let's go see if our application still runs. Awesome. So now we're getting a list of menu items, which include the ID, the name, the description, and the price. And we're seeing 2 of them. And let's just make sure that menu item works with a given ID. And then without an ID, I believe it'll give us a 404. And yes, as you see here, the 404, which is exactly what we want. Spring has some inherent validation that it automatically takes in the opinionated configuration, which I greatly appreciate. Just helps you get up and running and keeps you secure for whatever your data needs are. So now we have a working, configurable microservice Spring Boot application. We just need to look at the data set. As in a large application for a real restaurant, it would have a variety of items that could be updated, daily possibly, but probably not, probably weekly or monthly, in which case we don't want to make a code deploy after every item change. So we want to pull from some sort of data source, whether it be SQL or a NoSQL MongoDB, but that'll be in the next episode. So thank you so much for joining us. I hope you learned something, and best of luck on your microservice development endeavors. Thank you.